continuing our discussion about data, we're going to talk about a concept called the 5 V's of data. Now, you're going to see if you go search the internet, you can find 4 V's of data. You can find 5 V's of data. Sometimes you'll see 6. Sometimes you'll see 7. I've actually seen 8 V's of data. I think one time I saw someone write an article about the 9 V's of data. So people are always inventing new V's, but we're going to focus on the 5 V's and then maybe talk about 2 extra V's that we might actually care about. So when we're thinking about big data, the 5 V's, the ones that I've typically seen as the 5 V's, are volume, variety, veracity, velocity, and value. Even value, sometimes you don't see in all the lists. Sometimes it's the 4 V's. But I think if we talk, for whatever reason, when people talk about big data, they really like to talk about all of the V's that are involved. So let's jump into these V's. Volume. How much data do you have? Because I think that's an important question in big data applications. How much data do we have? Is there a lot of data? Is there a little data? Is there gigabytes? Is there terabytes? Volume can be a pretty important consideration. Not even thinking about where the data is. Like, are we storing data on individual servers? Is it cloud-based data? Is it replicated across 100 locations? Is it replicated or split into different pieces across different locations? Is it all in the same location but on multiple systems, multiple hard drives? Is it in a networked storage unit? Like, it's hard to say. So volume is a really important consideration when we're thinking about our big data issues. Variety is another important consideration. So how or what kinds of data is it? Is it tabular data? Is it numeric data? Is it text data? Is it document data? Is it image data? Is it video data? There's a lot of different kinds of data that we might encounter, and some of those may be very useful for some purposes. I think a lot of times, having a model that's built out of, or multiple models that are built out of multiple data sources can be effective ways to solve problems and build products. Veracity, how accurate is the data? This is an interesting problem because some data that we have is going to be pretty accurate. Some data is going to be read from sensors, which may be mostly accurate. Some data may be coming from social media sources. For example, if you have a social media site that's generating a bunch of data, Twitter, for example, you may have millions of tweets, but it's hard to say how many of those are accurate. So what do we do with this accuracy of the data? How do we evaluate that? You can do things like you can evaluate sentiment of text data, but evaluating the truth of text data is a very different kind of problem. So this is an important question, not only in the truth of the data, but like if we have a bunch of medical data, for example, is it actually accurately depicting what it should be? If you have image data, does it represent what we need to represent? So these accuracy issues can be concerning, and they can cause problems when we get into our machine learning models. Velocity. This is a really big question because you have to think about how quickly data gets created or how quickly data changes. This becomes an issue in a couple of different ways. If you have a website, something big like Facebook, that might be generating a lot of data through user interaction with your site, through creation of new comments, through uploading of images, but it also might lead to a lot of data challenges, around people clicking a button. How much time does it take for them to do a particular operation? What leads them to do it? How frequently do they visit? All of these sort of user operations can generate data too, so that velocity can be very high. Change data becomes an interesting problem too when we start thinking about big data, because the challenge with changing data is that we might train a model that works very well, but the world around us might change, and we're going to talk about that concept later in the class. It's called drift, but basically sometimes the world changes, which means that the data you have didn't change, but the world around you changed, so now your model's predictions might not be as valuable or as useful. And then value. What do we do with it? What can we actually use this data for? This is an important consideration because we could have lots and lots and lots of data, but if we can't use it to solve a problem, if we can't use it to do something for our product or enhance our capabilities, then maybe the data is not very useful. But one thing I will say is that data has become pretty inexpensive to store, so sometimes people just collect data and figure out what to do with it later. You don't have to answer the value question right away if you're storing data, and you can do that pretty cost effectively. 2 last V's that I've seen are variability. Like, what are the variations in the data? I think that one's a stretch, but like sometimes people include that in their V's. But visualization, I think, is a good one. If you have a spreadsheet, a spreadsheet can, like an Excel spreadsheet, can accommodate hundreds of thousands of records pretty well, and you can visualize data, build charts right out of that. Google Sheets can also accommodate data pretty well. Maybe not quite to the same level as Excel, but you can put a lot of data in a Google Sheet and you can visualize. But when you get into gigabytes of data, when you get into not necessarily hundreds of thousands of rows, but maybe hundreds of millions of rows, or maybe even billions of rows, visualization becomes a different kind of challenge. So thinking about how we're going to visualize our data in larger contexts is going to be pretty important. So these V's, they're important to present, because anytime you start talking about big data, people are going to the 5 V's, the 6 V's, the 7 V's. But it's just good to kind of have an idea of what they are and what they mean for us as we're solving our problems. That's all for now, and thanks for watching.